Good morning, students. Today I am taking topic differentiation, miscellaneous exercise, and some important questions of second order derivative. Now, question number 1: differentiate with respect to s of the following functions. First question is 3x square minus 9x plus 5 whole power 9. Differentiating it with respect to x, you know that here chain rule will be applicable. D upon dx of 3x square minus 9x plus 5 whole power 9. First apply the power rule of the function, then it will be 9 3x square minus 9x plus 5 whole power 9 minus 1. Now according to chain rule, into d upon dx of 3x square minus 9x plus 5. Thus we get 9 3x square minus 9x plus 5 whole power 8, and the differentiation of 3x square is 3 into differentiation of x square, that is 2x, 3 into 2x minus 9 into differentiation of x, that is 1, so it will be 9, and plus differentiation of 5, that is 0. Thus we get 9 3x square minus 9x plus 5 whole power 8 into 6x minus 9. Now there is question number 3, which is 5x whole power 3 cos 2x. Here function has power function, so we consider it as y. Y is equal to 5x whole power 3 cos 2x. Now taking log both the sides, this is the question from logarithmic differentiation. So log y is equal to log 5x whole power 3 cos 2x. Now by log rule, it will become 3 cos 2x into log 5x. Now differentiating both sides with respect to x, log y, that is equal to 1 upon y dy upon dx is equal to 3 d upon dx of cos 2x log 5x. Cos 2x into log 5x, here product rule will be applicable. So 1 upon y dy upon dx is equal to 3, and product rule cos 2x into d upon dx of log x log 5x plus log 5x into d upon dx of cos 2x. So this is equal to 3 into cos 2x, and differentiation of log 5x 1 upon 5x, and into differentiation of 5x, that is 5, plus log 5x differentiation of cos 2x, that is minus sin 2x, and into differentiation of 2x, that is 2. So we get 1 upon y dy upon dx is equal to 3 cos 2x 1 upon 5 x into 5 plus log 5x into minus sin 2x into 2. So dy upon dx will be equal to, cross multiplying y, you get 3y cos 2x 1 upon 5x into 5 minus log 5x into sin 2x into 2. This is equal to 3, and now put the value of y, that is 5x whole power 3 cos 2x into 5 cos 2x upon 5x minus 2 log 5x into sin x. Here within whole bracket, these all quantities are. So this is the answer. Now some questions from second order derivative. If y is equal to sin inverse upon 1 minus root of 1 minus x square, show that 1 minus x square d2y upon dx2 minus 3x dy upon dx minus y is equal to 0. For solution, we take y is equal to sin inverse under root 1 minus x square. Now we can differentiate both sides with respect to x. dy upon dx is equal to d upon dx of sine inverse x upon under root 1 minus x square. Here in left hand side, quotient rule of differentiation will be applicable. So this will become numerator d upon dx of, denominator d upon dx of numerator minus numerator into d upon dx of denominator whole upon denominator square. So this will become under root 1 minus x square, it is denominator, into d upon dx of sine inverse x, it is numerator, minus sine inverse x, it is numerator, into d upon dx of under root 1 minus x square, this is differentiation of denominator, upon 1 minus x square under root 1 minus x square whole square, that is denominator square, that will become 1 minus x square. Now in such questions we cross multiply and then we get the result. 1 minus x square will be multiplied with dy upon dx. Here two functions are now here, 1 minus x square into dy upon dx is equal to under root 1 minus x square d upon dx of sine inverse x, that is 1 upon under root 1 minus x square minus sine inverse x, and differentiation of under root 1 minus x square is equal to, first you apply power rule, 1 minus x square whole power half minus 1 into differentiation of 1 minus x square, that is 2x minus 2x, and now 2 cancel out, you get sine inverse minus x upon under root 1 minus x square. Now it become 1 plus, first we will cancel out under root 1 minus x square into under root 1 plus x sine inverse x whole upon under root 1 minus x square. Thus we get 1 minus x square dy upon dx is equal to 1 minus x into y. It is given value of y from first, sine inverse x upon under root 1 minus x square is y. So it becomes 1 plus x into y. Now differentiate both sides with respect to x. We get 1 minus x square into d upon dx of dy upon dx, that is d2y upon dx2, plus dy upon dx into differentiation of 1 minus x square, that is minus 2x, is equal to differentiation of 1, that is 0, plus differentiation of product of 2 x and y, so it will become 0 plus x dy upon dx plus y d upon dx of x, that is 1, so x dy upon dx plus y. Thus we get, taking all one side, 1 minus x square d2y upon dx2 minus 3x dy upon dx minus y is equal to 0. This is the result. Now there is some another question. If log y is equal to tan inverse x, prove that 1 plus x square d2y upon dx2 plus 2x minus 1 dy upon dx is equal to 0. So first we consider log y is equal to tan inverse x. So differentiate both sides with respect to x. Differentiation of log y is equal to 1 upon y dy upon dx is equal to d upon dx of tan inverse x, that is 1 upon 1 plus x square. And at such point we cross multiply. Never use quotient rule here. You cross multiply and get the result after differentiating it. It will become 1 plus x square dy upon dx is equal to y. So differentiating both sides with respect to x, 1 plus x square differentiation of dy upon dx plus dy upon dx into differentiation of 1 plus x square. Here it is the product rule of differentiation is equal to dy upon dx. Thus we easily get, taking all one side, 1 plus x square d2y upon dx 2 plus 2x minus 1 dy upon dx is equal to 0. And there is some another question. If x is equal to tan 1 upon a log y, then prove that 1 plus x square d2y upon dx 2 plus 2x minus a dy upon dx is equal to 0. Here given function is x is equal to tan 1 upon a log y. So you can take tan left hand side, it will become tan inverse x 1 upon a log y. And cross multiplying a tan inverse x is equal to log y. Now differentiate both sides with respect to x. You get a upon 1 plus x square is equal to differentiation of log y, that is 1 upon y dy upon dx. Now again cross multiply, you get 1 plus x square dy upon dx is equal to ay. So again differentiating, we get one. Here there are two functions in product form, 1 plus x square into dy upon dx. So apply product rule, and in right hand side a is the constant quantity, it will come out, and differentiation of y. So it will become 1 plus, again differentiating, it will become 1 plus x square d2y upon dx 2 plus dy upon dx into d upon dx of 1 plus x square, that is 2x, is equal to a dy upon dx. Now taking all one side and taking dy upon dx common, we get the result. There is another question. If y is equal to x power x, then prove that d2y upon dx 2 minus 1 upon y dy upon dx whole square minus y upon x is equal to 0. So given y is equal to x power x, here function power function, so we take log. So taking log both sides, log y is equal to x log x. Now differentiating both sides with respect to x, we get 1 upon y dy upon dx is equal to, here two functions are in product form, x into log x. So first function x into differentiation of second, that is 1 upon x, plus second function into differentiation of first, that is log x, into differentiation of x, that is 1. So we get 1 upon y dy upon dx is equal to x into 1 upon x plus log x. So dy upon dx is equal to, after cross multiplying, we get y, x cancel, 1 plus log x. So differentiating both sides with respect to x, d2y upon dx2 is equal to y into 1 plus log x. So again differentiate it, we get dy upon dx, d upon dx of dy upon dx, that is d2y upon dx2 is equal to y into differentiation of 1 plus log x, that is 0 plus 1 upon x. So it will become 1 upon x plus 1 plus log x into differentiation of y, that is dy upon dx. Thus we get du2y upon dx2 is equal to y upon x plus 1 upon y dy upon dx. The 1 plus log x has the value from above, 1 plus log x has the value 1 upon y dy upon dx into dy upon dx. So it will become d2y upon dx2 minus 1 upon y dy upon dx whole square minus y upon x is equal to 0. Now there is another question. If y is equal to log x plus under root x square plus 1, so that x square plus 1 d2y upon dx2 plus x log dy upon dx is equal to 0. Given y is equal to log x plus x under root x square plus 1, so differentiating both sides with respect to x, this is dy upon dx. Now differentiation of log, that is 1 upon x, means 1 upon the function 1 upon x plus under root x square plus 1 into dy upon d upon dx of x plus under root x square plus 1. This is according chain rule. Now this becomes 1 upon under root x square plus 1 into differentiation of x, that is 1, plus differentiation of under root x square plus 1. It is a half power of x square plus 1. So first you apply power rule, that will become 1 upon 2 x square plus 1 whole power half minus 1. So it will become minus half into d upon dx of x square plus 1, that is 2x. Thus we get 1 upon x plus under root x square plus 1 into 1 plus 2x upon 2 under root x square plus 1. 2 cancel out, you get 1 upon x plus x square plus 1, and taking LCM here, LCM is under root x square plus 1. 2 after cancelling out 2, we get under root x square plus 1 plus x whole upon under root x square plus 1. Now numerator and denominator x plus under root x square plus 1 cancel out, you get dy upon dx is equal to 1 upon under root x square plus 1. Now cross multiplying, we get under root x square plus 1 dy upon dx is equal to 1. So again differentiating it with respect to x, we get under root x square plus 1 into d upon dx of dy upon dx plus dy upon dx into d upon dx of under root x square plus 1 is equal to differentiation of 1, that is equal to 0. Now it is under root x square plus 1 d2y upon dx2 plus, now differentiation of that is 2x upon 2 under root x square plus 1. It is the half power of x square plus 1, so it will become half into x square plus 1 whole power half minus 1 into differentiation of x square plus 1. So it becomes 2x upon 2 under root x square plus 1. 2 cancel out, we get under root x square plus 1 d2y upon dx2 plus x dy upon dx upon x square under root x square plus 1 is equal to 0. Now taking LCM, it is under root x square plus 1, so it will become x square plus 1 dy upon dx plus x dy upon dx, and denominator will cross multiply with right hand side is equal to 0. Thus we get the result. Now you have to practice question number 5, 6, 7, 9, 11, 12, 13 and remaining. Here mean value theorem and Rolle's theorem are deleted from the syllabus for this year. Now thank you, have a good day.